Our last part of this unit is on a concept called percent yield. Now remember, in a chemical reaction, you have a sign called the yield sign. And in your reaction, you have your reactants, and then they yield your products. So in our last lessons, we focused on limiting reactants, how to figure out which reactant is a limiting reactant, because ultimately that reactant controls how many products we can form. Percent yield is a way that we determine the efficiency of our reaction. So the efficiency of production of our products. So percent yield always applies to the products in your chemical reaction, and we use this number to help determine the efficiency of our reaction to make sure we're not being wasteful. So the formula that we use to calculate percent yield is we take the grams actual, so the mass that we actually produced, you divide that by the mass theoretically possible, grams theory, and multiply it by 100. So how much you actually made divided by how much you could make if you did not waste any drop at all times 100. Of course, you want your percent yield to be as high as possible if you're in industry because you don't want any waste because you're out to make money, not lose money. So the grams actual, as I said, is the amount you actually make, and the grams theory is the maximum amount possible to make. It's the theoretical amount that is possible to make if you made no waste. Now, the way that you figure out the grams theory is you have to calculate it. Always. Again, you always have to figure out your grams theory. They're not going to give it to you. You have to calculate it. Now, the way that you calculate grams theory is you treat it kind of like the limiting reactant problems we just worked on in the last two lessons. You start with grams of your limiting reactant because that is what controls how much product you can make. It determines the maximum amount possible. And you convert it to grams of the product in the percent yield problem. This will always be a three-step conversion. I repeat, this will always be a mass-to-mass three-step conversion. So let's look at two examples today of a percent yield problem. Now this particular reaction, you have C6H6 reacting with chlorine, Cl2, to form C6H5Cl and then HCl. So this tells us we have a molecule called chlorobenzene that's used in the production of chemicals such as aspirin, dyes, and disinfectants. It goes on to tell you that it is prepared, because notice it is a product, it is prepared by the above reaction. It says when 36.8 grams of C6H6 reacts with excess chlorine, the actual yield of the C6H5Cl is 38.8 grams. Calculate the percent yield of the C6H5Cl. Now, I want you to notice a couple of things about some clues they've told you here. You know, in this reaction, you have two reactants. You have two molecules reacting. You have the C6H6 and the chlorine. Remember, one of these reactants will run out first, and that one is your limiting reactant. Now, if they did not tell you which your limiting reactant is, you would have to determine it, much like the problems we've looked at in the last two lessons. But look what they've done here for us. They've saved us some time. It says 36.8 grams of C6H6 reacts with excess chlorine. Look, y'all, they're telling you the chlorine is the excess. Well, there's only two reactants. So if the chlorine is the excess, that means that the C6H6 is our limiting reactant. Now, why is that important? Remember, on the last slide, I told you to find your grams theory, you have to start with grams of the limiting reactant. That's going to be what you start with to help you figure out grams theory. And you're going to convert it to grams theoretical of whatever substance they're asking you about in the percent yield problem. So I'm going to label these as we go. I'm going to call this the grams theory. calc for Graham's theory calculation. And it is a gram of the limiting reactant to grams of the C6H5Cl. That's my plan. So they told me I have 36.8 grams of the C6H6. That's my limiting reactant. And I'm trying to go to grams of the C6H5Cl. Gram to gram is 3 steps. So let's set this up for 3 conversion spots. 1, 2, 3. So I need grams of C6H6 to cancel. That means this is going to be our molar mass, because molar mass is the only conversion factor we have that has grams in it. So for the molar mass of C6H6, I'm going to come over here and figure that out. Of course, 6.06 for all 6 hydrogens, and for the carbons, it's 6 times 12.01. So that's going to give me 72.06. So let's add that to 6.06, and that gives me 78.12 grams per mole for the molar mass of C6H6. That will let grams of C6H6 cancel. So now we need moles of C6H6 on bottom, and I'm going to need moles of C6H5Cl on top. Mole over mole, this is our mole bridge class. So the numbers for the mole bridge come straight from the balanced equation. And I didn't really talk about it, but this equation is already balanced. It's a 1-to-1 ratio, everything. So 1 over 1. Let's continue on. That's going to let moles of C6H6 cancel. Now we need moles on bottom of C6H5Cl and grams of C6H5Cl. This is the molar mass, so since it is, it's grams per 1 mole. So let's figure out the molar mass of the C6H5Cl. So for all the carbons, there's 6 of them times 12.01. So that's going to give me 72.06. There's 5 hydrogens, so that's going to be 5.05. And there's 1 chlorine, so that's going to be 35.45. So let's add those together. So we have 72.06 plus 5.05 plus 35.45. And that's going to give me a grand total of 112.56 grams per mole. That molar mass plugs in here, 112.56. So that's going to let moles of C6H5Cl cancel. So let's take a look at the numbers we need to plug in our calculator. So our numerator, 36.8 times 112.56. And the only number in the denominator down here that we have to divide by is the 78.12. So let's punch in 36.8 times 112.56 divided by 78.12. So that's going to give me 53.0 grams of C6H5Cl. So that is the grams theory calculation. Now let's take a look at the percent yield. So percent yield calc. All right, so the formula for percent yield, I'll put percent Y, is grams actual divided by grams theory times 100. So grams actual, they actually told us that. The actual yield of the C6H5Cl is 38.8. So that plugs in here. So again, here's where you got to use your context clues. And we just figured out the grams theory. This is the maximum you could make if you made 100% yield. So 53.0 times 100. So we're going to have 38.8 divided by the 53.0 and then times 100, and we're going to round that to 3 sig figs. So the percent yield is 73.2%. 73.2%. Now y'all plug that in to make sure you get the same answer. Let's do one final example. So here we have CO plus H2 yields CH3OH. We have one carbon and one carbon, one oxygen and one oxygen, two hydrogens and four hydrogens. So we need to put a 2 here to give me 4. So 1, 2, 1 balances that equation. 75 grams of carbon monoxide reacting with excess hydrogen. Okay, so the hydrogen is the excess. That means the CO is the limiting reactant. So we're going to do our grams theory calc, because you always have to do that. That is always your 3-step problem. So we're going to start with 75 grams of CO. And we're trying to convert it to grams of the theoretical substance. So in this case, the only product is a CH3OH. So it says that this produced 68.4 grams of CH3OH. That is actual. It actually produced that, and it wants us to find percent yield. So gram to gram is 3 steps. I need grams of CO on bottom. This is my molar mass of CO here, grams per 1 mole. So carbon is 12.01. The oxygen is 16.00, and that gives me 28.01 grams per mole. That lets your grams of CO cancel. So now we need the mole bridge in our 3-step problem. The mole bridge comes next. So moles of CO on bottom, moles of CH3OH on top. So that's a 1-to-1 ratio. Finally, we need grams of CH3OH on top, 1 mole of CH3OH on bottom. So molar mass, you have 12.01 for the carbon. There's 4 hydrogens, so that's 4.04, and there's 1 oxygen, that's 16.00. So we're going to add that all up. That's 32.05 grams per mole. All right, so that lets moles of CO cancel, moles of CH3OH cancel, and you're ready to plug it in your calculator. So let's see what we're plugging in here. 75 times 32.05 and divide by 28.01. So let's plug that in. 75 times 32.05 divided by 28.01. So I got 86 grams, if you round that to 2 sig figs. That is your grams theory. So now let's plug it into the percent yield formula. Grams actual divided by grams theory times 100. The grams actually formed was 68.4 grams. That was told to us in the problem right here. We just figured out our grams theory. It plugs in down here, 86 grams. So let's figure out our percent yield. We have 68.4 divided by the 86, and then times 100. Rounding that to 2 sig figs, you get 79.5, which is 80 with a decimal percent. 80 with a decimal percent. Okay, so that is our lesson on percent yield.